Maxwell's equations in integral form. Physics for everyone welcomes you. First equation, Maxwell's first equation, Gauss law of electricity. Integration closed surface E vector dot dA vector equals Q enclosed divided by epsilon naught. The second equation, Gauss law for magnetism. Integration closed surface B vector dot dA vector equals 0. Third equation, Faraday's law of electromagnetic induction. Integration closed loop E vector dot dl vector equals minus d by dt of phi b. Then fourth equation, Ampere-Maxwell law. Integration closed loop B vector dot dl vector equals mu naught times Ic plus mu naught times epsilon naught times d phi e by dt. Let us learn one by one in detail. James Clerk Maxwell. Electrodynamics can be summarized in four basic equations known as Maxwell's equations. Maxwell's equations completely explain the behavior of charges, the behavior of currents, and properties of electric and magnetic fields. These equations can be written in integral form or integration form. First equation, Gauss's law of electricity. Here you have a plus Q charge. This is enclosed by a closed surface. Now, by Gauss's law, integration closed surface E vector dot dA vector equals plus Q by epsilon naught. Here, this term stands for the flux, phi E. But let us not write this as phi E because the phi takes a special form here. The flux over a closed surface. So phi E has to be replaced by integration closed surface E vector dot dA vector equals plus Q divided by epsilon naught. Suppose the surface encloses minus Q charge. Then by Gauss's law, integration closed surface E vector dot dA vector equals minus Q by epsilon naught. Good. Now the same surface, closed surface encloses two charges plus Q and minus Q. Now what is the net charge here? The net charge is 0. So flux will be 0. Integration closed surface E vector dA vector equals plus Q minus Q divided by epsilon naught, which is equal to 0. So flux through this closed surface equals 0. Good. Let us learn the general case. The surface encloses a charge Q. So integration closed surface E vector dot dA vector, which is the flux, equals Q enclosed divided by epsilon naught. Gauss's law of electricity. Integration closed surface E vector dot dA vector equals Q enclosed divided by epsilon naught. Let us learn the statement. The total electric flux over a enclosed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. Mathematically, integration closed surface E vector dot dA vector equals Q enclosed divided by epsilon naught, where E vector is the electric field and Q enclosed is the net charge enclosed by the surface. Let us learn the second equations. Gauss's law for magnetism. The enclosed surface now encloses a magnetic dipole. And please remember that isolated magnetic poles, a single north pole or single south pole cannot be available. They are available north and south together. So, the integration closed surface B vector dot dA vector equals 0. Gauss's law for magnetism, integration closed surface B vector dot dA vector equals 0 because the net pole inside the closed surface is 0. The surface integral of magnetic field over a closed surface is 0. Integration closed surface B vector dot dA vector equals 0, where B is a magnetic field. Let us learn the third equation, Faraday's law of electromagnetic induction. Here you have a magnet. Now I am pushing this magnet towards my left, where I have kept a ring. Good. It contains free electron. Now I am pushing this magnet towards the ring. What happens? This electron finds an electromotive force that pushes them in clockwise direction. Thereby, the current will be in the anti-clockwise direction. In that direction, you have the electric field. Good. Faraday law of electromagnetic induction. Integration over a closed loop E vector dot dl vector equals minus d by dt of phi b. The line integral of the electric field around any closed path is equal to the rate of change of magnetic flux through the closed path bounded by the surface. Integration closed loop E vector dot dl vector equals minus d by dt of phi b. Here the term integration closed loop E vector dot dl vector can be written as small e EMF E. Right? This is equal to EMF E. Right? But it is for a closed path. That is why we don't use E letter here. Instead of E letter, we use integration closed loop E vector dot dl vector, where E vector is the induced electric field. Fourth equation, Ampere's Maxwell law. Here you have a capacitor. Now this capacitor is charged by a time varying current. Let us consider a loop L1. In this loop, let us apply Ampere's Maxwell law. Integration closed loop L1 B vector dot dl vector equals mu naught times the current enclosed. Here the current enclosed is the conduction current IC. Let us consider another loop between the plates. It is L2. Here let us apply the law. Integration closed loop L2 B vector dot dl vector equals mu naught times the displacement current ID. This displacement current ID is given by a formula epsilon naught d phi E by dt. So let us combine the two integration. Let us write it as one. Integration closed loop B vector dot dl vector equals mu naught times IC plus mu naught times epsilon naught times d phi E by dt. Let us learn the statement. The line integral of magnetic field over a closed loop is mu naught times the net current, conduction current and displacement current enclosed by the loop. Mathematically, integration closed loop B vector dot dl vector equals mu naught times IC plus mu naught times epsilon naught times d phi E by dt. Here the B vector is the induced magnetic field. Here the phi E, right, has to be replaced by integration closed loop B vector dot dl vector equals mu naught times IC plus mu naught times epsilon naught times d by dt of the phi E is replaced by the electric flux is replaced by integration closed surface E vector dA vector. You know why I replace this? Because phi E is a general electric flux term, but now we are going for the specific form closed surface. That is why the phi E is replaced by integration closed surface E vector dot dA vector. Now for a free space, right? Integration closed loop B vector dot dl vector equals mu naught times epsilon naught times d phi e by dt. In free space, there is no conduction current at all. The change in electric flux leads to the displacement current that leads to change in magnetic field over a closed surface. Here there is a match the following. The first equation, integration closed surface E vector dot dA vector equals Q enclosed by epsilon naught. This is nothing but Gauss law of electricity. Then integration closed surface B vector dot dA vector equals 0. It's nothing but Gauss's law for magnetism. Then the third one is Faraday law of electromagnetic induction. Of course, the fourth one is Ampere's Maxwell's law. Thank you, children.